Very good.
Where do you even get a tripod like that all together?
REI.
Where?
REI. REI. It's a store called REI.
Yeah, that's what
Obviously, your results are number one, and everybody get exactly the same number, which means there's something else I should be able to do.
I was like, I was like, after
Why is one page different from D? Why are those grades different? Because one of them does something the other one doesn't do, or wants more or something. That's what kind of shows you visually what's going on. Right, look at the previous group A. Say they're all clustered, aren't they, in the middle? They're all close to the mean. What about for group D? You get further away, exactly, right? So it's that. That's what's different between all of it. As you move down from group A to group D, it's more and more different.
if you meet them. We have the same practice. I have my friend and then I'm getting one this weekend. Next week I have 5 But we got this video 17. And the singles in the middle, the keys, the mirroring straight now. But I was like, afraid to be in trouble.
All right, guys. Let me put you out of your misery. I love you guys so much. This is exploration. If you had trouble with number 1, you should be concerned. If you had trouble with number 3, you just got to review maybe, but that's what was on that last test, right? Number 2 and number 4 are the new stuff we're talking about today. And it was just trying to push you in the direction of seeing why we need to do what we're going to do today, to look at data. So one reason we calculate the center is so I can really quickly tell somebody something and they know what the data sort of looks like. So if I said the average income at this company is $50,000 a year, all right, kind of, okay, good. But there's something more I need to know. So if the average income is $50,000, does that mean everybody makes $50,000? Could it mean that? Yes. If everybody made $50,000, the average would be $50,000. Right? But there's a lot of ways to make an average of 50,000. There's a lot of ways to make an average of 13. There's a lot of ways to make a median of 13, blah, 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 as you just found out. So what is the difference between these sets of data? I keep doing that for some reason.
Spread.
The spread. Yeah, it's how spread out the numbers got. The group A is spread out the least. And then it gets a little more spread out, a little more, and you should see that in your answers to number 3. So let's catch up. Everybody, what'd you get for all of them? They're all the same here. What was the mean?
13.
13. The median?
13.
13. The mid-range?
13.
13. The mode?
13.
13. And the range?
14.
14, but that's sort of a different thing anyway. So all the centers said 13. Now, the reason I want you to calculate the range also, the range is not a measure of center, but it seems to be a measure of spread in a way, right? You guys kind of with me on that? Isn't the range kind of giving me an idea of how spread out the data is? But isn't it the same for all 4 of those? So the range is not good enough to capture this idea of how spread out the numbers are. And what do I mean when I say spread? It's how far the data gets away from the middle. So group A, we had a ton of people that scored the average exactly. So it didn't get very far away from its mean. Group D, we had 2 people and then they kind of spread out from there. They got far away from the mean. So group D's spread number should be bigger than group A's spread number. Does that make sense? So if I told somebody the center of the data and I told them how far away on average data points get. So if I said the income there is 50,000, the average income, and the spread number is 10,000. So that gives you an idea of 40 to 60,000, 30 to... If I said the spread number was 80,000, well, somebody's making a ton of freaking money because they're really spread out far away from 50,000. Are you guys sort of getting this? So this is what the thing is. I want to boil all data sets down to two numbers: the center and how spread out the data is. Those two numbers give me a really good feel for what the data looks like. So instead of looking at 800 data points, I just say, what's the average and what's the spread? Right?
Sounds like a football game.
Huh? Yeah, well, yeah. If anybody bets out there, you want to beat the spread and all that kind of crap. But no, it's well, sort of related, to be honest with them. Now, I understand I should have asked this first because everybody got wrapped up in what you did. Analysis-wise, it seems that they're all the same. If you just look at them, they ain't all the same. So this is no, they're not the same, obviously. And this one, does that agree? No, it doesn't agree. Because this, when I did this, didn't say that they all look the same. So I really want to make sure you guys are okay with this. That doesn't mean that all of this is crap. It just means that this is not enough. Finding the center is not enough. I need something else. Alright, so very quickly, for Group A, what were your numbers? Let me put the classes down here. So somebody read off their numbers here. What was it, just one? One. Wait, how do you get a 1 there? Wait. Zero, that's better.
No, it's 1.
Yeah, it's 1. Okay, let's try it. 1, 0, 8, 0, 1. Okay. What about B?
1, 2, 4, 2.
Alright, is that what everybody got?
Yeah.
Okay. 3, 6, 10. You gotta make sure there's 10 data points. What about Group C? Yeah, 2. Let me make sure I'm with you. 2. 2. 2. What about Group D? 3. 1. 2. 1. 3. So do you see how Group A, most of the data points stay close to the average, right? And then as you move away, now here there's still a decent number that's kind of close to the average, but they definitely spread out a bit more. Do you guys see that? And then here, now they've definitely spread out. They're just like all over the place equally, so that's even more spread out than Part B. And then Part D goes even a little further. It pushes more of them out farther. So Part D would be the most spread out data. So we're going to actually come up with an equation that represents the average distance that the data points get away from the mean. How far on average are the data points from the center? Doesn't that make sense? That would be the spread of the data. Okay, I remember. Okay. So the differences are, I heard some words like that varies more in some places, the spread, what else? Consistency. Right, Group A is more consistent than Group D. Anybody else say something different? So I heard the word vary, which is cool because it's a word we use in statistics. How consistent they are, the spread of the data obviously is a word I use a lot. Does that kind of make sense? How spread out it is. If you're somebody who puts peanut butter in your sandwich and you're done, or you're somebody, I want to spread to all the edges. Get that peanut butter. Okay, that's more spread out peanut butter. All right, I like it. All right. Now we're all hungry. Oh, before you go with it. All right. So, here we go. So let me ask you this. How do I find the average anything? If I wanted to find the average age in this classroom, how would I do that? I get all your ages, add them all up, divided by how many there are. So if I want to find the average blank, I add up all the blanks. So if I want to find the average age, I add up all the ages. If I want to find the average blank, average height, average weight, average whatever.
All the data.
I add up all the blanks and divide by how many there are. Does that make sense? All right. Now what do I want to get here? I want to get the average distance from the middle. So what do I have to get first? Before I can average the distance from the middle, I have to get all of the distances from the middle. Let me stop. So if I wanted the average age, I got to get all the ages. If I want the average height, I got to get all the heights. If I want the average distance from the middle, I got to first get all the freaking distances from the middle.
You're down to the data, right?
Okay. And our data now is going to be this distance from the middle. And of course in math, what's distance? What do we use for distance in math? Subtraction. Right. So, I'm going to do, doesn't really matter, I'm going to do one of these for you and then you guys can divvy up. Let's do group A because it's the least interesting. And then I'm going to have you guys do the other three. So here's what group A would look like. It's a 6 and 20, right, with a bunch of 13s? Don't write this down on yours. You want yours blank for the B, C, D, whatever you guys do. You with me? Just watch for right now. 13. So what was the mean? The mean for everybody was 13. So we call how far a data point gets away from the mean, we call that the deviation. So what would you say if you're walking down the street? Have you heard this word deviant? Deviant. Deviant. If you said somebody's a deviant, what does that mean?
That they are against society, not the same.
They're away from the normal. They're away from the average. They're not the same. You probably want to cross the street, right? Don't judge based on anything except if you know something. Oh, he's a deviant. Let me go over there. Because they're away from the average. So we call this distance from the middle deviation. So for example, what is 6 minus 13? Negative 7. It's crazy. 6 minus 13 is negative 7. All of these are going to be what? 13. So how far away is 13 from the middle? 0 away, because it is 13. So all these are going to be 0. And then this one, how far is 20 away from 13? 7. Let me let that sink in. So I just want to take each data point and then find out how far away from the mean it is. Now I have a negative because that data point was below the mean, and I have a positive, that data point was above the mean. But what do you get when you add up all these? 0. You get 0. Shit. I really want you guys to be with me. That would happen for whatever data I was using, wouldn't it? Because the mean would have equal amounts below it as it would above it. That's what the mean does. So that is always going to add up to be 0. So right now you should say, well, that's lame, Jeff. Good job. Yay, Jeff. Good job. Everything's 0. You suck. But if I stop there, then yes, I would suck so hard. But what can we do to kill a negative? We can square it. So what I'm trying to do is I'm trying to get the average distance from the middle. So I got a bunch of distances from the middle, but of course they're always going to add up to 0. So what I'm going to do is I'm going to square them. So at the end I'm going to have to do what to undo that? How do I undo squaring? What's the opposite of squaring something?
Divide.
Square root. I like it. 3 squared is 9. What do you do to 9 to make it 3? You square root it. Okay. Stay with me now. So what is negative 7 squared? 49. 0 squared is? 0. What's 7 squared? 49. It's crazy. Now add those up. What do you get when you add these up? 98. Alright, really. So here's what we're trying to get. Hang on to that for a second. I'm going to leave this up here when you go to do yours so you have something to reference. We're trying to get the average distance from the mean. Alright, now go with me for a second. So what we want to do is we want to add up the distances from the mean and divide by how many there are. But there's 2 things we have to do. One thing we just talked about. We've got to square these so that I kill the negatives. But I really want this heart of it should make sense right there. What would I get if I did this? The idea is I want to sum up all the distances and divide by how many there are. Then I should end up with an average distance from the mean. That idea is there. Why do I have to do that weirdness? Because otherwise it would always have to be 0. Well, that sucks. So
So that means at the end I have to take a square root to kill the squares. Kill it with fire. Stop there for a second. Stay with me now. So again, let me do this again. If you've got it, great. Hang on to it. When I add anything up and divide by how many there are, I get the average that. Right?
Right.
If I added up the ages, divide how many, I'm going to get the average. Okay. So I'm adding what? What are these? What are those? Sorry. Apologies. What are these? What is that? What does that represent and what does that represent? What does this represent? The data points. All the data points. So it's each data point and how and subtracted the mean. So that means, what does this represent? What does that represent? The deviation, yes. So it's how far the data point gets from the mean, right? So if I add those up and divide by how many there are, I'm going to end up with the average distance from the mean. That's going to be the spread. On average, how far do the data points get away from the mean? So if that average was 1, my data is really tight. On average, they get 1 away from the mean. If that comes out to be 20, now it's a lot more spread out. So to give you an example, on tests or quizzes, the spread of grades is normally around 13 or so. So on average, people get 13 points away from the average grade. So there are some people that get hundreds, and there are some people that get 30s, and the spread comes out to be about 13. Right? So I can see if it's tighter or if it's wider. If it's like 20, that worries me, because that means there were some people that totally got it, and some people just totally didn't get it. That's when I get some people with 20s and shit like that. I hate that. So I want the spread to be tight and the average to be high. That's always nice. Okay. So again, we square it to kill the negatives. And here's a weird little adjustment. This is only a sample. It's not the entire population, right? This is only a sample. So to adjust for it being just a sample, I don't divide by n, I divide by n minus 1.
What does that say on the bottom under the adjust?
It's an adjustment for it being just a poor little sample.
Okay.
If it was a population, I wouldn't have to do this. But since it's a sample, this is what I do to adjust it a little bit, because it's just a sample. We don't have all the information. So let me see if I can explain that a little bit. Now, real quick, there's a lot of concepts flying around. Do you agree that the math involved is not horrific? I mean, the math involved in this, and you guys don't know to agree or not, but I mean, it's a bunch of subtracting and squaring, and who cares? It's not hard. The concept is what keeps people down. So I'm trying to give you an intro to the concept, so those of you who go into statistics go in a little more comfortable with this idea, because this is huge. The idea of this is what's called standard deviation.
That's what that formula is
Yes,
called?
deviation is how far you are from the middle. Standard is like you're standardizing that, saying on average, standard, what's the standard distance from the mean? What's the average distance from the mean? So that's what standard deviation means. And it's huge in statistics. So from right now, if you don't understand much of the ideas surrounding it, as long as you can actually calculate it, I'm cool with it, because I'm letting it percolate in your brain before you got to take stats. So let's figure this out for this data. Do we have everything we need? Do I have my pen? I did something with my pen. Go on, let's get another one. So tell me, what is this? What is the whole thing? What is that whole thing? What number can I put in place of this whole thing? And what does this mean? This means I got a bunch of these. Where are these? Yeah, that's here. Aren't these here?
Yeah.
And then what does it say to do to it? It says add them all up. So when you add them all up, you get 98. So I replaced the top. The entire top, the whole top is 98. That's another thing that confuses the hell out of students. But again, like I told you, cover that up. I need a column of these. I add them up and I put the number there. Bam. You're not plugging stuff into here, because how many things would I have to plug in there?
10.
Yeah, screw that shit. I did all the work ahead of time. What's the sum of all of those? 98.
And what's n minus 1?
Right.
9. I love it because there's 10 data points. So now if you plug that in your calculator, let's see what you get. So I get square root, got it. Square root 98 divided by 9. I get 3.2998. You can't really see that, but there it is. See it? Is that what you guys got? 3.2998. So on average, the data got about that far away from the middle. That's what that means. So what's going to be true about if I did group B? What the number that I get at the end, is it going to be more or less than this? Is group B more spread out or less spread out than group A? More spread out, right? Group B is a little more spread out than group A was. So the number that measures the spread, should it be higher or lower than this?
Higher.
Higher because it's more spread. So do it. Do B, C, and D. Figure out amongst yourselves who's going to do what. Do the same thing we just did. And there's the formula for it there.